All right. So this is College Physics 1. My name is Guy Lakin, and today I'm just going to start by going through the syllabus, take questions about the format of the class. We'll go over like the grading structure, what kind of homework I expect you to do and that kind of thing. And half of the class has lab tonight, and the other half has it on Wednesday. This week's lab is going to be really fast. It's just, there's this bubble sheet, like multiple choice exam we're going to do. It's the only multiple choice thing we'll do this semester. But a way to sort of test how much your kind of intuition about physics has improved over the semester. That's not really what this class is designed for, is like your intuitive, like it's more focused on doing problems. But we always hope that intuition comes along with problem solving. So we're going to do a pre-test, post-test on how that comes along over the course of the semester. And so the lab tonight is just taking that test. And so the test only takes half an hour or something. Once you turn it in, you can leave. So we'll ease into the semester gently. Yeah, I know. That's what everybody likes to hear about labs. And, okay, let's go through the syllabus. So there's no book required for this class, and as far as just understanding what you need to do in this class, getting ready for homework problems, getting ready for tests, I would recommend that you don't look at the book. I mean, I think the book is written for, the person who wrote the book has in mind what he thinks it means to understand this material. And but my tests are based on what I consider to be the important things. And my lectures are just exactly designed by me to, to get at those points that I'm trying to test on the test. So if you go to someone else's sources or whatever, you're getting someone else's take on what's important, someone else's priorities. I think you'll be happier if you just focus on what I'm saying. And if you have trouble understanding something I'm saying, then, come talk to me about it. I think you'll be happier if you do it that way than if you spend a lot of time trying to get outside explanations from, Khan Academy or textbooks or whatever. Like, I think those are I'm not saying those aren't useful sources. I'm just saying if you're concerned just about being ready for exams, homework for this class, these lectures are specifically designed to get you ready for those things. You know what I mean? Yes?
Are there any topics that might class that we might expand on?
Yeah, that's a good question. Yeah, probably, yeah. But I think mostly it'll just be the amount of depth I go into. You might find when you look at an MCAT practice exam and something is like, okay, well, we did cover that, but not really in this way or whatever. I think that with this class, you'll get to the point where like an MCAT study book or whatever will be enough of a supplement. You can get the extra information you need. So I don't think you would need a textbook for that. Textbook definitely, if I just started reading through the textbook, I couldn't do it in the lecture time we have available in this class. So obviously there's a lot more information in a big textbook than I'm giving in my lectures. And so if you want to expand on anything, or you want a more complete listing of like all the equations that could be useful for this stuff, a textbook is useful for that. Okay, so everything that I'm going to want you to, all the materials that you need for this class are on D2L. So anybody who hasn't used D2L before, that's the first thing you need to do is figure out how to get onto D2L. If you go to the main Normandale webpage, there's a link up in the corner, D2L. and you need a star ID and a password to log in. If you don't have those, you can talk to IT, probably emailing IT. You know, I know they're probably not there right now, but if you email them, they can help you. So log in. It all looks different than it did last spring, so I think I know where I'm going. So you have a front page like this. I don't know if yours looks just like that, but if you scroll down, eventually you find your list of classes that you're taking. These are the 2 classes I'm teaching this semester. So here's College Physics 1. And when you go into the College Physics 1 D2L page, there'll be a list of announcements. And as I add new things, I'll just scroll down here. And I think it's always going to be the top one that you're looking at. And when I update homework problems or post new solutions or that kind of thing, or there's new information that you need to know about a lab or something, I'll try to remember to post an announcement here to say that it's there and mention it in class. And then over on the right side, so there's the announcements. It'll be, you know, it's a good idea to get in the habit of checking this page maybe every day or every other day, something like that, pretty often. Over here is where all of the materials are going to be. So it says course information, practice problems, solutions, lecture notes. So first we're going to go to course information, and I'm going to go through the syllabus. Okay, so here's the syllabus. And I teach a ton of sections of this. You are either section 91 or 92. So if your lab is Monday, you're 91. If your lab is Wednesday, you're 92. And then there are day sections too. And by the way, the fact that there are all these, so there are 5 different lab sections, and that could come in handy if you can't make it to a lab one week. If you can't make it to your scheduled lab, but maybe you can make it to the other night lab, or maybe you can, most of you I know are working during the day, but if you happen to be able to make it to a lab during the day, you can just do your lab at that time instead. I would like it if you'd talk to me about it beforehand, at least at the beginning, just to make sure that we have enough seats and, you know, we don't have any labs with 35 people in them, because it's really hard to make that work. But so checking the schedules and stuff is probably going to be useful at some point. Contact information. I'm Guy O'Lakin. My PhD is not in physics, it's in engineering, engineering mechanics, which has to do with like deformations and loads being applied to objects, like the kind of things you'd use this kind of engineering stuff for designing, you know, big structures in civil engineering, or for making sure that engines aren't going to explode when they, you know, when you apply these kind of loads to them. So I'm not really a physicist. So a lot of times people, you know, will come up and ask like, oh, you know, I just heard about this new physics discovery, you know, people in Switzerland figured out you can do this. And it always sounds cool to me when I read about that, but that's not my area. I don't know anything about that kind of stuff. So like the physics of really fast, really tiny stuff, modern physics where stuff happens that doesn't seem possible, or that's the stuff I don't have any background in. I can try to help find sources for you. I might know a little bit about questions you might have, but that's not really my thing. But the good news is that the basic physics that like the sort of traditional classical physics that I use in all my engineering stuff is, the same stuff that you teach in this class. So this stuff is right in my area. My office is S2302, so there's stairs right at the end of the hall that way, and my office is right at the top. But actually, my office hours are going to be in different rooms anyway, so you probably don't need to go to my office very often. The best way to get a hold of me is email. I'll usually get back to you pretty soon. If I don't, here's what happens. Here's what happened if you write me an email and I don't get back to you. It's like I looked at your email and I made a mental note to write back to you, but then that mental note immediately that didn't do anything. I thought it did, but it didn't. And then this many people wrote emails after that, and then your email got pushed below the bottom of my screen, and then that was the end of it. So if I don't reply to an email, just write again and say, politely, you forgot to respond to my first email, and then I'll feel bad and I'll write back right away. That works pretty well. My phone you can call, but I don't even have, I'm notified when I get messages. I can check messages and whatever. But that's not actually a great way to get a hold of me. Email's better. But if you call and leave a message, I can get that too. Office hours. So I do office hours sort of like in a study hall format in the labs for the night classes. So I'll just open up the lab rooms. You can come in whenever you can make it. Spend a couple hours on Monday before class working on problems. If you get stuck, I'm there. Hopefully there'll be other people in the class there working on it and you can work together. And my experience is people who get in the habit of every week making it to some of those office hours, work on stuff with other students, ask me questions. Those students always seem to do really well in the class. The causation could work either way, but it does seem to help. And then I have one office hour on Tuesday and one on Thursday during the day. That's probably not as useful to you, but that's in the tutoring center. So S1324, that's the room that the lab is in. So you'll, when you go to your first lab, you'll see where that room is, but it's, it's just the one door down from here. So it's a little confusing. Monday, I have 2 office hours before class, right before class. Wednesday, I only have 1 of them, and that just is because on Wednesday I have a lab that goes up until 5. But so those days aren't totally the same. Sometimes on Wednesdays, if you do get here at 4, I'm just doing a lab for physics next door, and we're in the last hour of the lab, so a lot of times, there'll be room, you can sit down, people will already be going, you could ask me questions and stuff. So if you do come at 4 on Wednesdays, we can probably find a place for you to sit down and work. Okay, what do you need for this class? Materials, you just need a scientific calculator with trigonometric functions. It needs to have sine and cosine on it. You don't need a book. We were talking about that just before class started. No textbook is required, and I always have people come in after the first exam or something, and they say like, can you recommend some textbooks for me to read? I didn't do as well on the first exam as I wanted to, or whatever. I can give you suggestions for how to improve things if they start out badly, or if you want to start out now, you want advice now on how to maximize scores. But like I said, I just wouldn't recommend that a textbook be part of it. I'm doing everything I can to make my lectures exactly answer the kinds of questions that you're going to be asked on homework and tests. And I have some suggestions for how to maximize what you're getting out of the lectures. But really, I think that's what you have to go on. And when I first started teaching here, this is my 10th year, start of my 10th year here. Yeah. So when people would ask me for textbook recommendations, I would give it to them, and it just seemed to never, like, if people were already sort of struggling and then they started spending a lot of time looking at other resources other than my notes, it just never seemed to help things in the right, make things go in the right direction. I never remember a case where somebody asked for outside information, outside resources, and things got better. What you want to do is just figure out how to make the lectures work for you as well as possible, But if you want outside resources, especially for like future reference, the book that I'm most closely basing my lectures on is Physics, Principles with Applications from Giancoli. And I think it's up to like the 7th edition now, but you can probably find earlier editions that have roughly the same information. Like mostly what they do when they do new editions, they will sometimes add new sections and stuff, but mostly they just move the problems around. Like they make problem 13, now it's problem 7 or whatever, so that it messes people up who try to. So, like if your problems are coming from the book in a class, then the professor assigns problem 13 and it's the wrong problem. They're just trying to get your money. So the good news is you don't need the textbook for the problems. Those will all be posted. So you can just get whatever edition you can get for $40 or whatever. I don't know. And then this is a really nice resource, actually, that every scientific class I took after I discovered them, I got the Shams outline of that class. They have, I don't know, hundreds of them probably, and they cost like $15 each. They're paperback. They have little concise descriptions of all the topics. So they're not really designed to be like a primary, like how you learn the material. They're meant to be sort of refreshers. But they do have little refreshers on every topic. And then they have tons and tons of problems with solutions to a lot of them. And the ones that don't have solutions, I think they have answers to all of them. So if you're trying to get ready for like the MCATs or any other kind of standardized test where you need to practice a lot of physics problems, this is a great place to go. $15, so if you don't use it, you haven't spent a lot of money. The prerequisites, there's only one of them. That's Math 1100, that's college algebra. At the end of class today, or after I finish going through the syllabus, I'll write some problems up on the board and give you a little time to try to think through them. And they're not graded or anything. It's just an example of the kind of math that we're going to see in this class, and a way for you to kind of gauge for yourself, is your math level about right for this class? Probably a lot of people will be a little rusty on it, but it's just to give you an idea of what the rough level of math in this class is going to be. Because the biggest, I'd say the single biggest thing that causes problems in this class is that people just, they're in the wrong physics class. They're, if your math isn't at the right level, it just makes everything seem 100 times harder than it really is. You think the physics is really hard, and it's not really the physics you're getting stuck on. It's just the math, so. And then the website for the class is D2L. Like I said, get in the habit of going to that regularly. Everything will be posted on there that you need. Okay, before I go on to topics and stuff, does anybody have any questions about what I've said? Okay. will. Topics for this class. Physics is generally, the first 2 semesters of physics is usually broken up basically into what they call mechanics in Physics 1, which is like being able to calculate how objects will fly through the air, what happens if you apply a certain force to an object, talking about friction, the kind of things that you can actually go out and test with your hands, like stuff that by the time you're 5 years old, you've dealt with all these things. And so a lot of it, you already have developed some intuition about. The bad news is, for everybody, a surprising amount of your intuition that you've developed about this stuff is wrong. And so some of the stuff that we're going to have to do in this class is actually trying to erase some of those bad habits, the bad intuition that you have on the way things work with mechanics, and replace it with the new stuff, the accurate stuff. And then the second semester of physics is mostly electricity and magnetism, stuff that's not as intuitive. So we're not doing any of that this semester. We're just talking about balls rolling, things sliding, pushing on things, sort of the world of your everyday experience. Okay, grading for this class. So I have a higher grading scale than people are usually used to, 92, 82 for A's and B's, and then C's go down to 70 and D's go down to 60. That grading scale has just basically come from experience as I've done this class. Like, if you go through all the lectures, you understand what's going on, you do all the problems, I don't think getting above 92 or 82 is very hard. So even though it looks like maybe I'm being like it's a hard grading scale, I think you'll find that what I ask you to do based on what I give you, it really is not that hard of a grading scale. And I'll talk about how the lectures and the problems that I give you as assignments relate to the exams and stuff later as I go on in this. The final grade is broken down into 70% exams, 20% lecture quizzes, 10% lab exams. And so the short story there is that your entire grade is based on basically different kinds of tests. But, okay, and that makes some people nervous, I know, because I know there are people who often don't do as well on tests as they feel like they've done on the homework assignments and that kind of thing. And, I think to some extent, I always had that experience too. So, I mean, I'm, sympathetic about that. What I've done is I've tried to do 2 things with all of these tests that will make people feel like they're fair. One is I make sure that you have plenty of time for these exams. So you're never going to be like racing against the clock. If I've written this test the way I mean to finish it. We always have 80 minutes for a test, and I try to write them so that half the class will be done and out of the class in an hour. So half the class will be gone 20 minutes early, half the class will stay for the last 20 minutes. But I think you'll find that, you're not just trying to write as fast as you can. You have time to sit there and think about it and look and think about something else for a while. Like, I wonder what text messages I've missed since I've been sitting. And then go back and do it, and it'll work. And the second thing that I'll do is all of these test questions are going to be if you're familiar with the problems that I've given in labs and in homework assignments and the example problems that I've done in class, the problems that you're going to see on exams are going to look really familiar. I make all of the problems that I assign and the examples I do are meant to be, similar to the kinds of problems that you'll see on exams. And so I think that'll, that helps with the thing that I know is sort of everybody's testing nightmare, is that like you'll look at a problem and your mind just goes blank, like you don't know what to do at first and you sort of panic and then that sort of spreads. Well, the idea is if you've done all of your homework problems that I've assigned and the lab problems and gone through the notes and the examples, you'll look at the problem and it'll look like something you've seen or multiple problems you've seen. And hopefully that and the fact that you have a lot of time will will make you feel confident that you know what direction to go. There is, by the way, if anybody has a lot of test anxiety or really has significant trouble finishing tests on time, there's OSD office here, Office for Students with Disabilities, I think is what it stands for. But most of the people who I'm aware of going there are just going for an extra quiet test environment or extra time on tests. You have to go in and have an evaluation done and they can tell you whether it's reasonable for you. But if you always have had trouble with testing, and it wouldn't hurt to go to the office. And so OSD office, you can find it on the Normandale webpage and find out if they offer any services that can help you, But my experience has been that people have felt like, even though the entire grade is based on different types of tests, the overall experience that people seem to have had is that it feels fair. People feel like their knowledge of the material is being fairly evaluated. Okay. I would like to collect assignments and go through them carefully. It is a helpful thing. I'd love to be able to give you that feedback to everybody, but I just have so many students in these taking college physics. It doesn't end up being that useful. I end up just writing down a number on it and whatever. But you're always welcome when I assign these problems. If you write out all these problems in like a notebook and then come into office hours with this notebook full of problems you've done, I'd be happy to go through these problems one by one with you and tell you, like, yes, this is the right way to think about it. Here you're missing something important, that kind of thing. So I can give individual feedback that way. Any questions about grading? I'm going to go now into detail into the different parts of the class, the problems I assign, the format of the exams. But does anyone have any questions before I do that about the grade setup? Okay. So on D2L, there are practice problems, and you can think of those as like the assigned problems. So every topic that we go into, there's a set of probably 10 to 20 problems in that, for that section. And after every class period, if you go to the announcements in D2L, it'll say assignment for Monday, what is it, the 21st? 821, and it'll list out what set of practice problems you're on, and then numbers 1 through 6 or something. And then that's kind of like your assignment for that class period. You're not turning them in, so if you want to, like everybody has days where they just have a lot of stuff going on. And so if you put it off, it doesn't directly affect anything. But overall, I would recommend trying to stay on that schedule. I'm going to try to give a schedule that sort of steadily walks you through the material. And if you put off too many of these problems until right before the exam, it's just not going to soak in as well, And then these practice problems. So, well, let's look at that. So in D2L, go to the table of contents. Okay, so practice problems. These are all the topics for the class. First set has to do with converting units and stuff like that. And so these are all the problems. And underneath practice problems is a section called practice problem solutions. And there's not a solution for every problem. Let me check, see if that's true. Okay, that one does have a solution for everyone. Okay, so it's not every problem, but it's most of them. I'd say it's probably 80% of the problems that are listed in the practice problems, there are full solutions written out for. You're trying to understand how to go through the process of solving these. And when you get to exams, these aren't going to be the exact problems that are on the test. The idea is just that the test problems are going to follow a similar thought process of solution to the ones that the practice problems that have been given. So what you don't want to do is look at the problem, look at the solution, and try to remember how to do it and work through it. What you want to do is look at the problem, spend some significant amount of time trying to work through it. Hopefully you can do it because it's similar to example problems I've done in class and stuff. And then if after you've thought about it for a while, tried for a while, you just can't figure it out, then go to that part of the solution for like a little hint, So the solutions are there, but if you rely on them too heavily to do the problem, you sort of trick yourself into thinking you're learning how to do it when you really haven't, Okay, so going back to the syllabus. The exams are going to be based on, like, the ideas in the exam are going to be based on the ideas in the practice problems. If you understand the practice problems well, I think the best way I can explain it to, like, how do you know when you're ready for an exam? I think I would explain it like this. If you get to a point, if you can get to the point where you could go through, you can look at the practice problems and explain step by step as you write it out to somebody else why you're making, taking the steps that you're taking at that time. If you can understand why you're doing each thing at each step of the solution, then you're going to do very well on the exam. Okay. If, like, I'm trying to make the distinction between sort of memorizing how to do one of these problems. You know, if you spend too much time with the solutions, you kind of memorize the steps, that's probably not going to help you too much on the exam. You need to understand why you're doing each thing you're doing. And if you get to that point, then the exams will follow sort of the same thought process. Any questions about the practice problems? Okay, the exams. There are going to be 5 exams. None of them is worth more than another one, so each one is worth 14% of your grade. And if your score for the last exam, which we take during the finals period, is higher than any of your first 4, then that exam 5 score is going to count as itself, and it'll also replace the lowest score of the first 4. So if you really bomb one of your first 4 exams and you do well on the final, that'll erase the low score and put a high score in its place. So that's great, right? The one catch is at the time that I give these exams, I'm not offering any makeups at that time, okay? So if you miss an exam, then for the time being, that exam is just a 0. And then when you take your exam 5, that exam 5 score is just going to have to replace that 0, you know? So it's sort of an incentive for people to be at all the exams, but it gives you some wiggle room too. I mean, I know things come up, and if you don't make it to an exam, that doesn't hurt your score. You still get to replace it with that exam 5. Under very unusual circumstances, come talk to me, and maybe I can give you a makeup at that time. But for the most part, I just want you to think of it as like the exams are on the dates that they're listed here. If you miss it, you get a 0, and you use your final to replace it. Okay. These are the timing of the exams. One other thing is if you can't make it to one of these exams, so yours are on, I guess, all on Mondays. If you can't make it to the exam on Monday night, but you can rearrange your work schedule a little bit and make it to the afternoon class to take the exam, you can do that too. I know that's not, for most of you, that's sort of difficult, but if you absolutely can't make it to the night class, but you can find a way to make it to the day class, then that's a way to take the test and not have to replace a 0 later. Any questions about the exam setup? Yeah, that is the one that you have to take, yeah. I mean, you don't have to do anything, but you get a 0 on it. That's what I mean. Yes. Oh, yes, thank you. All of these exams are cumulative at that point. And so as I'm assigning problems, I'm going to do it in a way that keeps making you circle back to old material. So I'm gonna do my best to try to help you keep up with the old stuff as we go by it. But yeah, every exam is cumulative. And then So 70% of your grade is based on exams. 20% is based on what I'm calling lecture quizzes, which is sort of the closest thing I have to like collecting homework. And these lecture quizzes work like this. Every couple weeks, and all the dates are listed here, in the last 15 minutes of class, I'll give you a few questions about just recalling stuff from lectures. So that's to encourage you to go back and reread your notes. And there'll be one or two questions, also problems that were assigned in the homework, and it's just going to ask you to, recreate those, write those problems out. So that's to make sure that you're doing your homework problems and then sort of refreshing your memory on them occasionally. So with these lecture quizzes, I sort of think of it like this. In a lot of classes like this, over the course of the semester, you have, over 100 pages of textbook stuff assigned to you that you're supposed to read. And I'm not assigning that to you. But what I would like in place of that is for you to spend that extra time not just writing the notes or glancing through them once or whatever, but just really making an effort to understand what I'm saying well, because to me, the things that I'm saying are the really key points. And so with these lecture quizzes, I'll ask some question about, and I'll try to focus on the biggest points, but I could ask, like, under what conditions does this equation apply? And it'll be something that I said directly in the notes. And to do well on these quizzes, you're going to need to be able to recall that stuff. By the way, in my assignments each day, reading over certain notes is always going to be part of that assignment. So again, just like I'm going to try to keep you, with the assignments, I'm going to try to keep you refreshing old problem approaches. I'm also going to try to get you to, lead you towards reading the right notes so that it sort of stays in your head, That's my goal. And then the last thing is the lab exams. They add up to a total of 10% of your grade. And the dates of the lab exams are listed here. I take attendance at labs, and the biggest number of labs you can miss is 2. So if you miss 3 labs, you just don't pass the class. But besides that, the only way that labs come into your grade is through these lab exams. And during the labs, I'll talk about those in more detail at the labs, but it's going to largely be exercises in developing your physics intuition. And you'll be working on problems in groups, and the lab exams are going to be very similar to the problems that you've done in labs. Okay, and don't cheat. Okay, general policies and comments. So let me go to I'll do number 1 last. Everything that you need is on D2L, so you need to go to D2L regularly. Try not to fight with each other, and definitely try not to fight with me, for God's sakes. I'm sensitive. But, sometimes it happens, every class it happens at some point, like you think someone asked too many questions, or like that guy took my seat or whatever. Yeah, you get annoyed with people. You've been working all day, you come here, it's not really what you want to do. People get annoyed. Just we'll get through it, So number 1, attendance will not be taken in this class. So you never have to come. But if you don't come, you're responsible for that information, obviously. But here is what's available there. So the reason I'm doing these lectures on this computer is because after the class is over, I can make a PDF of everything that I've written. So let me show you what that looks like. That's on D2L2. So it says current lecture notes. This should actually say old lecture notes. These are the lecture notes from last fall. But let me just go to one at random. So there'll be PDFs on D2L of everything that I wrote on here. And you can print that out. And then, while you have this in front of you, on YouTube, I have the lecture videos that I'm making on the computer as I go the whole time. So let me show you what that looks like. I don't think you're going to be able to hear the audio here, but for outside resources, and they've started reading through this other textbook that I recommend or whatever. Yeah, that's not coming through. But back on track. I think your best bet for that's a bad one to do. Let me do one that where I'm writing something. When people, like if people have been struggling in the class and so they've asked for it. Okay, so the first exam. Is that coming over the ceiling or just through my computer? Okay. Bye. I don't know.
Thursday, the 22nd.
Okay, so
you have the force on the beam.
Oh, this is a different class, by the way. This isn't physics. This is an engineering class. But
then you get to the.
It gives you the idea. You know, you can see what I'm writing. You can hear what I'm saying, and so you have the notes in front of you.
Contact forces between the pulley and the beam.
And you can write little notes in the margin while you watch the video. Just treat it exactly like you're in class. And I think, that'll be a nice resource, especially if you miss class. But even if there's something that happens in class that you want a second crack at understanding, you can rewatch on this. Yep. Yeah, I'll put it on the announcements on D2L. You can also just go to YouTube and search for Guyer Lake and College Physics, and it'll come up. And I'll put a link on there and I'll just make a playlist of the whole class. Study guides. I guess I don't exactly have anything like a study guide. I mean, in a way, I would say the practice problems are the study guide. You should know how to do those kind of problems, and if you can do that, then you're in pretty good shape. But if anyone would like more, come to office hours, and I'd be happy to, outline or talk about ways to approach studying or that kind of thing. Okay. Any other questions about, well, first, any questions about the videos or the notes or anything like that? So what I have here, what it says current lecture notes, I have to change that to say old lecture notes, but that's everything for the last time I taught this class, which is going to be very similar to what I do this semester. Some little things will change, but for the most part, that's it. And then there'll be another one that says current lecture notes, and that's where after each class, I'll post the PDF of what I said that day in class. So if, I don't know, you can think about how you want to approach it. If, you might want to just, like maybe some of you might want to just sit here and listen to what I say, or write down sort of an outline of what I'm saying as I go, and then rely on the PDF of what I said later for the details. You could do that. You could, you could just use the PDFs if you miss class, whatever. I did have someone ask me one time, like, if there's any way that I could post the PDF before class, and that's like a fundamental misunderstanding of how this PDF comes into existence, But short of that, I can make any of these things available to you anytime you want. Okay. Yes. Yes. Yeah, Gaio, please. Yes. So that's everything I think I want to say about the class overall and the syllabus. So the next thing I want to do is I want to just give you these 5 math questions. I want to give you a few minutes to work on it. And then I'll go through solutions for these because, maybe you're curious. But remember that the big idea here is I want this not to look just totally foreign to you, because this is stuff you're going to have to, the kind of stuff you're going to have to be able to do in this class. I think it'll probably be a pretty small section of this class that can correctly do all 5 of these problems, but that's not really the thing. I just want it to look somewhat familiar. I want you to feel confident that you took the classes where you did this kind of stuff. And I want you to feel like, okay, if I had to do these problems by next class or whatever, I know what math book to go look at. I could figure out how to do it. For anybody that this looks totally foreign to, we should talk about this class, because there is a physics class with a lower math requirement that might be a better choice. I should also say that if there's anybody here who is taking this class for engineering, any kind of engineering, we need to talk right away, because for engineering you need a physics class that's based on calculus, and this isn't it. So we need to get you switched into the right class right away. Okay, so math quiz. Question 1. Plot the function y equals x squared. Second question. Calculate the slope of the line that goes through, I'll say, between points 1, 2 and 4, 3. Simplify this expression. So you're not going to be able to come up with numbers for these variables, but you can just simplify this expression to a simpler expression in terms of these variables. So the starting thing is a b squared c squared over e to the fourth times the square root of c. Then question 4, solve this for the variable a. A squared times b times c is equal to 4c plus b squared c squared. So again, on this one, you're not going to come up with a numeric answer for a. You're going to come up with an expression for a in terms of b and c. And then the last one, solve this system of equations. X1 plus X2 is equal to 50. So that's the first equation. And then the second equation says 2x1 minus 3x2 is equal to negative 10. And so this one, number 5, you are going to be able to come up with numbers for x1 and x2. Okay, so take a few minutes, see what sense you can make out of these 5 questions. Feel free to, talk to the people next to you. If you don't take this opportunity to work with the person next to you, there's a danger that you might miss out on making a very nice friend. Okay. Okay, so yes, see what you can do here. Like I said, you don't have to turn this in, but just so the first one. So we're plotting the function y equals x squared. One way you can do that, if that shape isn't something that's just automatically in your head, is you can pick values of x, square them, and that gives you the y position. So if x is equal to 0, square that, y is equal to 0, so that's a point. If x is equal to positive 1, square that, y is equal to positive 1, so that's a point. If x is equal to negative 1, square that, y is equal to 1, so that's a point. And then if x is equal to 2, 2 squared is 4, so that's a point. If x is negative 2, square that, y is positive 4 again, and so you get something like this. And that's called a parabola. And parabolic relationships are going to come up a lot in this class. The place that's going to come up most often is that when objects are in free fall and air resistance is minimal, well, let's say free fall or projectile motion, their path is always parabolic. And also, if you plot, instead of plotting the y position of an object versus the x position, if you plot its y position versus time, that also is a parabola. So that's where this shape is going to come up pretty often. Anybody have any questions about the first one? And then the second one, the 2 points are 4, 3, and 1, 2. So to figure out the slope between those 2 points, we're just going to use rise over run. Slope is equal to rise over run. And so we're going to choose one of these points to be, it's arbitrary, but we're going to choose one of them to be sort of the destination and one the starting point. So let's think of it as going from the point 1, 2 to the point 4, 3. So then the rise is the destination minus the starting point, looking at the y values, because those are the ones that relate to how high something is. So the rise is 3 minus 2. And the run, that's the horizontal change, is equal to 4 minus 1. And so we get a slope of positive 1/3. So if I plot these out, the first point is 1, 2, so that point, and the second point is 1, 2, 3, 4, 3, so that point, and we calculated the slope of this line between them. And so the bigger the value is, that's like the steeper this is, the closer it is to vertical. And positive is rotated counterclockwise from horizontal. So this one, you can see, is rotated just a little bit counterclockwise from horizontal. Any questions about that one? Okay, third, we're simplifying that expression. So A times B squared, I'm going to write that as B times B, times C squared, C times C. And then in the denominator, we have B, 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 e to the fourth, times A, times the square root of C, and I'm going to write that as the square root is C to the 1/2 power. And so the A's cancel. 2 of those B's in the numerator cancel with 2 in the denominator. And then the C's, we have to use an exponent rule for that. So what happens to the exponents of the C's if you take, like what, if you, so here's my question. What if you have C to the M divided by C to the N? Do you remember what the exponent is of the answer there? Yeah, so the answer is C, the power of M, not M divided by, sorry, M minus N. Okay. So what that gives here is we have C squared divided by C to the 1/2. And so that comes out to be C to the 3/2. And the only things that, besides the C's that we haven't canceled, are these B's. So I'll call that B squared. There's a few formats you could use to simplify it, but that's the basic idea. Any questions about that one? and then 4. So for 4, we're trying to come up with an expression for A in terms of B and C. So A squared times B times C is equal to 4C plus B squared times C squared. If we're trying to solve for A, that means we want to get A by itself. So I'm going to first get A squared by itself. So A squared is equal to 4C plus B squared C squared, all divided by BC. And then if A squared is equal to this, we can use the square root to represent A. So A is equal to square root of all this. And then there's one more thing we have to do. Well, we could simplify that. That's true. I'm going to leave it like this. I'm happy enough with that. But there's one thing that, so right now this is plus or minus. Yep, exactly. So what this is saying, that whatever A is, you square it and you get this. Okay? So let's say that this is, that all this comes out to be 1. Okay? Let's say all this is 1. What are the 2 possible values of A that could give you, that when you square them, you get 1? Yeah, 1 or negative 1. And that, I mean, I remember, taking this stuff in math and being like, it's sort of nitpicky, or you get a point off on a test, like, that's pretty nitpicky. But in physics, those are 2, those are 2 possible solutions for what the motion of something is. And you need a reason to differentiate between one or the other one. And so this is going to be a big thing in this class. It's not a, like I said, I remember it feeling nitpicky in math. In physics, these have 2 different physical meanings, and we need to be clear about which one we're dealing with. So plus or minus, 2 different answers. Okay. And then the last one is the system of equations. So we have x1 plus x2 is equal to 50, and 2x1 minus 3x2 is equal to negative 10. If your math class where you talked about this stuff was like mine, you probably learned several ways of solving things like this. In a way, I think knowing several ways to solve for it actually makes it feel more complicated, because you're like, okay, which one do I use? Well, substitution always works. So we're not in a rush. Let's just say systems of equations, we're just going to solve by substitution. Okay. I mean, if you're happy with doing something else, do it. That's how I'm going to approach these in this class. So I'm going to use the first one to do, and as sort of a rule of thumb for substitution is use the simplest of the equations to come up with your substitution, and then plug that into the more complicated equation. So for this first one, let's say x1 is equal to, I'm going to subtract x2 from both sides, so we have negative x2 plus 50. And then I'm going to plug that into the second equation, so we have 2 times all of this stuff minus 3x2 is equal to negative 10. So we have negative 2x2 plus 100 minus 3x2 is equal to negative 10. And now we can combine the like terms. And that gives negative 5x2 is equal to negative 110. And now we can just solve for x2. We get that x2 is equal to 22, right? And are we done? We did the hard part, but remember that what we're trying to do is come up with solutions for both of those two variables. Now you can plug that into, as long as we didn't make any mistakes, every equation we have following the initial problem statement is correct. So just find the easiest one you can, plug into that. So I'll take x equals 22, plug it into this one, and it says x1 is equal to negative 22 plus 50, and so x1 is equal to 28. Any questions about that one? Okay, well, let's stop there. I'm not going to assign anything for Wednesday, but on Wednesday we'll get to the real physics material, and I'll give an assignment after that. Okay, and let's do, even though all we're doing is this bubble sheet pre-test in the lab for the half of the class who has lab tonight, let's do it over in the lab room, just in case there's anybody who missed the lecture and is going to meet us over there, all right? So it's right next door.